Hello friends and neighbors. We're taking a little bit of time today to think about how we name simple chemical compounds. Now, I don't know about you, but when I go to the grocery store and someone is handing out free samples of this wonderful stuff, my family just cringes and disappears anytime the salesperson says, "You've got to try this stuff. You will love it. It's chemical free." And I look at it and I say, chemical free? How do they do it? How do they put it in a box and have no chemicals and still charge money for it? I wish I could do that. Well, 100% chemical free. Knowing how to name chemicals may help you with things like this. It might help you look at these two chemicals: salt and vinegar potato chips and a hand warmer, the kind that has the little push button in it, and you push it and it turns white and gets warm. What do those two things have in common, and what is their names? How do you assign a name to these things? Well, there's a set of rules in chemistry, just like there is in any foreign language. There are a set of rules in the language of chemistry. And today we're going to look at the naming rules for compounds that have... We're going to look today at the naming rules for compounds that only have two elements in them. That's what that binary means right there. Binary compounds with just two elements. Now, we're going to be looking at two different naming systems for binary compounds. One for binary compounds that are ionic, and one for binary compounds that are covalent. Two different naming systems. And before we really start into that, there's a piece we need to understand. You'll notice, I'm going to go back to that slide, that really the way we can tell if a compound is ionic is if it starts with a metal. If it has a metal as the first element. If both elements are nonmetals, it's covalent. So it's going to be very important for us to be able to look at an element and then look at its symbol and say, metal, nonmetal, metal, nonmetal. Kind of close to the line and hard to tell. Oh, okay. Well, on your periodic table, you should put a line like this, if there isn't already a line there. That is the line that separates the metals from the nonmetals. Everything here is a non-metal. Everything over here is a metal. Now, I know there's some people out there that will look at hydrogen and go, okay, hydrogen has some properties of metals. It has one valence electron, and they'll list some other things, and they'll say it has properties of metals, but it also has mostly properties of nonmetals. So I tend to classify hydrogen as a non-metal. So be able to look at a periodic table and decide, is it a metal or a non-metal? Now, there are some really important properties of things right here at this dividing line where we're getting to be more metallic as we move toward this line, like this. The elements become more and more metallic. You'll look at iodine, you'll even see that it has a metallic sheen to it. But these are still nonmetals as long as they're in this part of the periodic table. Metals. Now remember, our line is right here that divides the metals from the nonmetals. And I'm going to draw my line right there to divide metals from nonmetals. You'll find that metals generally have only one or two or three valence electrons. Usually. Of course, we've got some important exceptions over here. More valence electrons, but usually 1, 2, or 3 valence electrons. Now that contributes to the reason that metals conduct electricity, but we're not really focusing on that right here today. Metals tend to lose electrons because they have a low affinity, a low attraction for those electrons. And so when two atoms get together, if one is a metal and one is a nonmetal, the nonmetal tends to have a greater attraction for the electrons, and the metal tends to lose that electron or those electrons. So that's an important identifying characteristic of metals. Now that means they become cations. Yes, that word is pronounced cation. No, I don't want to hear you saying cation. It's a cation. Okay, and of course the metals are on the left side of the periodic table. Now, can you tell the nonmetals? Remember, our ziggity-zaggity, wiggly-waggity line is right there, unless you can come up with a better name for it. And I'm going to personally include hydrogen in this, even though it only has one valence electron. Most nonmetals have 4 or more valence electrons. I mean, here's an exception to that. Boron only has 3. Helium only has 2. But for the most part, more than 4 electrons for the nonmetals. They have a greater attraction for electrons. They just, because of the arrangement of the electron shells and the charge of the nucleus, you tend to get a larger attraction for the electrons from other atoms. So when you put a metal together with a nonmetal, the nonmetal has a greater attraction for the electrons and tends to steal them away. It tends to gain electrons and become negatively charged. That's what this anion thing is here, is a negatively charged ion. Nonmetals tend to be on the right-hand side of the periodic table. So now we're going to think a little bit about naming compounds with 2 elements. You have just learned how to identify whether something is ionic or covalent, looking at an element and its symbol, and based on its location at the periodic table, predicting, hey, this is going to be metal or nonmetal. And then, of course, remembering that ionic compounds will start with metals, and covalent compounds will start with nonmetals. Now we're going to find that naming ionic compounds, these very simple ones that we're starting with, is very easy. We just look at the name of the cation. Remember, that's what we call positive ions. And the name of the anion. That's what we call the negative ions. And we just write their names. And they will always end in IDE. In fact, both of these, all binary compounds, end in IDE if you're using the rules of the International Union of Pure and Applied Chemistry. Now, covalent compounds, if they're binary covalent compounds, they use prefixes to tell how many of each element are in the compound. And we'll look at some examples of that here in a moment. In fact, right now, here we have naming rules for binary compounds. Now, you're going to get a list of these prefixes. You don't have to memorize them, but you kind of need to learn how to use them. So I've placed here a set of hypothetical compounds of nitrogen and oxygen, some of which may only exist briefly under unusual circumstances, but for purposes of illustrating how to use, how to name these, I think this will be useful. You don't ever need a prefix if there's only one of the first element, but if there's one of the second element, we always use a prefix. So we're going to write the nitrogen is the name of the first element. And we have oxygen, but there's only one of them, so we're going to put the prefix for 1, and of course it ends in IDE, nitrogen monoxide. Now here we have 2 nitrogens, so we're going to put a prefix of di for 2, dinitrogen, and once again we have 1 oxygen, so it's going to be monoxide once again. Now in this example we have 1 nitrogen and 2 oxygens. We don't have to use a prefix with only one of the first element, so we're just going to write nitrogen. And now we have 2 oxygens, so the prefix for 2 is dioxide. Nitrogen dioxide. And this 2 nitrogens, 3 oxygens, that's going to be dinitrogen trioxide. And you can look up those prefixes that you will have on your reference sheet. The trickiest thing is to remember this, not needing a prefix if there's only one of the first element, but needing the prefix when there's only one of the second element. That's really the trickiest thing of this naming system for binary covalent compounds. Now, we're going to look now at naming binary compounds that are really simple. None of the transition elements are present here, and you'll see what changes that in a moment. So we're looking here at ionic compounds, and how can I tell they're ionic? Well, it's going to be a methyl first and a nonmetal second. You just have to remember, look back at that periodic table and say, is this first element on the left-hand side of the periodic table, the left-hand 2/3 of the periodic table? If it is, hey, this becomes easy. In fact, it's so easy that all we have to do is write the name of the cation and the name of the anion. It's really just that simple. Here the cation is sodium and the anion is oxygen. Well, actually the ion is always going to be called oxide. So this is sodium oxide. And here we have calcium and phosphorus. So that's going to become calcium phosphide. And magnesium and oxygen is going to become magnesium oxide. And here, sometimes people forget their symbols. What's K? What's K? Okay, it's potassium. What? Potassium. This is selenium, so this is selenide. An E there at the end. Now, those were really simple. Yes, it has to get harder.